This is uniform.
Yeah, that section is like.
So that is a BB here.
Okay, so okay, never mind.
Okay.
So BB falls on the upper, like right above the surface of the longer one. It's not actually that whole
Depends
interface.
on how you select.
Okay.
So here we select it right here, but BB could be also just the very narrow, very short, very close distance to here. So BB could be here, right? So basically, for your selection is you just select a little bit below. So that would be the eligible choice. So from here, you expect they should have the very large discontinuity in the distribution of the shear stress from this end to this end. Okay. Everyone know his questions? His question is why not we select the BB as in this range? So that means a little bit below that interface. So that this one as a BB. And my answer is yes, you can select that one. So that means just a little bit below that kind of the interface. In this way, you can see choose the narrow, shorter one or choose the longer one. They're both okay, but in this way, just very close to the interface, the corresponding shear stress, the magnitude of shear stress will be different. So that means once we cross in this level, you will see that there's a kind of a jump in the value of the shear stress. The same thing happened to here. And if you can choose this one as AA, that's okay. Okay, so but most of the time, for example, for exercise or for homework, we will precisely tell you which segment you use in your calculations.
So then if you use the other area for your Q, would you then use the longer length or would you use the shorter one? Or does it not matter again?
In terms of homework and the testing, I will precisely tell you which one.
Okay.
But in terms of design, then that would up to your justification. Which one will be your interest?
But you also said earlier that QBB would be equal to the same for that.
And let me show you right now. So the question is this. So for example, if this is our, let me simplify the problem statement. So if this is a cross section, okay, we make that easy. And this is the centroid. And for this section, we have transverse loading V like this. And so in this way, this is our neutral axis. So say if we want to calculate a level, that level is, say, take this one. So for example, is this level here, the red one. So the red one representing is this level here. Okay. So that representing is we are interested. What I draw the level representing is the red line here. Actually, we are interested representing is this one. The total force on this side. To the viewpoint to you become the line. Actually, if I tilt it, is an interface representing is a level there. Okay, that is the one we're interested in. So now we come to the Q, and I told you that Q for this level. For this level, we can pick up either side. For example, let me pick up this side. Okay. And that side, let me call this area is A1. And then this one, for example, let me label it. Let me call that is a Y1 bar. Okay, so Q can be I1, A1, Y1. The second option, you can pick this shaded area, which means on either side of the level you pick of the entire cross section. So which means this level simply bisect into two portions. Either portion for you to calculate Q will be fine. The magnitude of the Q will be the same. And right now I'm going to show you why. So that means here is 4 will be equal to, let me call this is A2. And for this green one, this is the centroid. Centroid to here, let me call that is a Y2 bar, or A2 Y2 bar. And Y1 bar. either this one or either this one, for sure, that will be fine in terms of magnitude. And y, the two terms, this terms and this term, has the same magnitude, which means they just have the same magnitude. I'm going to show you why now. Why? This is the original cross sections, okay, and this is the neutral axis. We know this is the geometry, so usually A1 plus this is the area 1, this is area 2. So let me label it. N, 1, 2, and AN. A for 1, that is A1. For this one, that is A2. And then for YM bar, that is Y1 bar, that is Y2 bar, right? So that's the tabulation you use to calculate the centroid of the cross section, right? So I just repeat the process. So in this way, the AI, Y, the AN, YN, so that is the A1, Y1 bar, and A2, Y2 bar. So from here, we know that calculation is this. The AN, YN bar will be equal to the total area multiplied with the centroid of the total cross section. So for this case, the centroid is here, is 0. Right? So that means A1, Y1 bar plus A2, Y2 bar equal to 0. So that means A1, Y1 bar equal to minus A2, Y2 bar, but their magnitude are the same. Again, I simply put into these tables. Everyone familiar with this table. You use this table to calculate the Y bar for this cross section, which happen is 0 here, right? Okay, the same thing. If I use this one, the same. The centroid is here. That is Y bar is equal to 0. Okay, I use the coordinate. So that means if we take the absolute values, then they both have the same magnitude. So guarantee once you have a level here, you either pick the either side for your cube, and you'll get the same magnitude. Why they have a negative sign? That representing that they have a negative sign simply it tells us on the same interface, simply a corresponding shear stress is opposite to each other because that is the action reaction. Think a little bit more. That one is a little bit beyond this, the contents of this class. But that is the physics behind this one. But anyhow, here the rule is you pick either side. And for me, I always pick the side that has a simple geometry. And for this case, of course, I always pick is the bottom side. Yes.
Is there a linear relationship between A and BB?
No.
Or,
no.
So you have to take the
That would depend on the value of the two things will depend on the 1, 2, 3, 4. And this one is fixed. V is fixed. So the value really depends on the Q and T. And sometimes I can make up one very weird the cross section, for example, like this. Okay. And so that can tell you the kind of feeling. No, there's no relation. So here I use this example to go through very detailed calculation and give you a lot of the meaning of these things. And this one we're still in the beginning, and the next one I want to go with is this formula, okay, using this one. And this one probably we can do it on Friday. And we still have a few minutes. Let me ask you one quick question using this example. In terms of our design, and usually we concerned is the maximum stress is less than or equal to the allowable stress. So now the question is, where is this maximum? And how big? As long as you can determine a level where corresponding to the maximum, then you should be able to calculate it. Again, we look at these equations. For this equation, V is constant V and I should be fixed across the whole section. So you simply, if you want to calculate maximum, yes, go ahead. So you have to find a way, you have to find a level. So now my demonstration, by the way, if you dump your trash, if you have kind of, if you would find any sponge, bring over to me. I'm going to make a more model, teaching toys, that'd be very useful. If you would think the cross section of different shape, okay, on that shape, it depends on your engineering. Try to pick a level. That will give you the maximum value of Q and minimum value of T. That is the ideal scenario. But not always happens, right? So for this case, we try, that is our goal. So let me give a try. So say, hey, let me guess, it's here. I make one guess and I do the calculation. And then I make a second guess. And second guess is here, so this is right in the middle. So that means here is 80, 40, this is 60, and here is 60. So simply I make another guess is at the middle, and I do another calculation. I compare. So from here, really from after comparison, I believe from our engineering justification, you should be able to refine your search for the place, and that will give you the maximum. Yes.
Just to go through just really quickly conceptually, if you did choose it like in the middle at 60 and 60, your Q would then be, it would be
half of the.
It'd be half of this.
No,
like,
Q won't be because this one is not the same size.
What would your Q be? Like, because you have to.
So this
what
one.
Would your Q like incorporate the shape? Which shapes would it incorporate?
Then that really depends, and you simply go forward. Is you simply calculate the corresponding Q.
Okay.
Yeah.
So you would have to include all of that.
The either side. Once you determine the level, you pick the either side for your Q calculation.
You pick either or.
For example, if we have the level here, then you have to pick either this side
or the
other
yeah,
side.
No, I'm saying that you have two. You kind of have two rectangular shapes.
So either this side or this side.
Yeah.
This side.
So you have to find a center of the middle.
Yeah, that will include in this part. So that is a portion.
Yeah.
Okay. So again, for the maximum, square, and the value, you have to determine